Hello class, today we're going to talk about section 9.5, which is the quadratic formula. By the end of today's lesson, you'll be able to state the quadratic formula and use it to solve quadratic equations. You will also be able to find the discriminant and determine the best method for solving quadratics. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. It is extremely important that when you are using this formula, your quadratic is written in standard form. So ax squared plus bx plus c. X squared has to come first, x has to be in the middle, and any number value has to be last. So if your quadratic equation is not in that order, you need to rearrange it to make sure that it is before you can plug it into the quadratic formula, which is again negative b plus or minus the square root of b squared minus 4ac all over 2a. So we've got x squared minus 12x is equal to negative 20. Right now my equation is not in standard form, so I need to add that 20 over to the left side of the equation, and I end up with x squared minus 12x plus 20 is equal to 0. I am now ready to plug into the quadratic equation. So I'm going to take the negative, aka the opposite of my b value. So I'm going to have 12 plus or minus the square root of my b value squared, so negative 12 squared, minus 4 times a, which in this case is 1, times c, which is 20, and that whole thing is going to be divided by 2 times the a value. There's a lot going on in this equation, so it's very difficult to plug into a calculator at this point. So what you're going to want to do is a few simplification steps. So we've got 12 plus or minus, simplifying the squared part, negative 12 squared is 144. And then I've got 4 times 1 times 20. 4 times 1 times 20 is 80, so we're going to subtract 80. And simplifying 2 times 1 is 2. It is still a little bit complicated to put this into the calculator and deal with parentheses. So I'm going to simplify 144 minus 80, which is going to give me 12 plus or minus the square root of 64 over 2. At this point, it is possible to plug this into your calculator. When you are typing this into the calculator, you need to be very careful to make sure that this top part is in parentheses. So in our calculator, it would be parentheses 12 plus square root. Remember, you get to that square root sign by hitting the second and then the x squared button. So square root, and it's going to give you a parentheses. You're going to type in 64 and then close that square root parentheses, and then you need another parentheses to close that first part. And then you're going to say divided by 2. When you plug that into the calculator, you get an answer of 10. You can then use the up arrow on your calculator, and it is going to give you this exact equation back again. You can go in and change the positive sign, the addition sign, to a negative sign. So you've got your same equation now with subtraction, and you are going to get an answer of 2. So your two answers are x is equal to 10 and x is equal to 2. Go ahead and try this one on your own. Again, opposite of negative 24 is 24, plus or minus the square root of negative 24 squared minus 4 times 35 over 2 times 4. Simplifying, we get down to 16 under that square root. We know the square root of 16 is 4, so I can add 4 and subtract 4, and you get a final answer of 3.5 and 2.5. We're going to go ahead and try another one. So we've got negative b, so the opposite of that is 2 plus or minus the square root of negative 2 squared minus 4 times a times c all over 2 times a. Again, going through and simplifying, we're going to end up with 2 plus or minus the square root of 4 minus 108 over 6. Taking that next simplifying step to simplify under the square root, I end up with 2 plus or minus the square root of negative 104 over 6. As I pointed out in the last lesson, we do not have the capabilities to take the square roots of a negative number. So our answer, if your square root part ends up being negative, is no real solutions. So once again, if you get to a negative under that square root, you can stop the problem and identify it as a no real solutions. This leads very nicely into the discriminant, which is that part under the square root, so the b squared minus 4ac. That's used to determine the amount of solutions that we have. If the square root value is positive, we're going to end up with 2 solutions. Those were the first 2 problems that we did. If the square root value is 0, we're going to end up with 1 solution because adding 0 and subtracting 0 are going to give you the same answer. If that square root value ends up being negative, that was that last case that we looked at, and there is no solution. So part of this is just being able to find the number of solutions instead of actually finding the answer. So I'm still going to have my equation in standard form. So adding 3 to both sides gives me 4x squared plus 5x plus 3. Since it's asking us to find the discriminant, we just need to take b squared, which is 5 squared, minus 4 times a times c, which is going to give me 25 minus 48, which is equal to negative 23. Since our discriminant is negative 23, that means we have no real solutions for this problem. Go ahead and try this one on your own. We have to add 11x to both sides, making sure that that ends up in the middle because that is your b value. So we're going to take 11 squared minus 4 times 2 times 15, 121 minus 120. The answer is 1, which leads us to conclude that there are 2 solutions to this problem. The last thing I want to talk about is we've gone over 3 different ways to solve quadratics. Chapter 8 spent the entire chapter talking about these factoring options. And then now in Chapter 9, we've talked about 2 more, which is completing the square and quadratic formula. There are times when you should use each of these. Factoring you should use that when the c value can obviously break down into numbers that you can easily solve for. Completing the square is when there are no obvious factors of c and you have a leading coefficient of 1, so that x squared is just a leading coefficient of 1. Quadratic formula is best when the leading coefficient is not 1. It also can really be used in any situation, so if you prefer to just be consistent and use the quadratic formula for all of them, that is definitely a possibility. I'm going to give 3 examples of how to do each of these, just as a refresher. So for factoring, we are looking for the numbers that multiply to 20, that add up to negative 9. So I've got 1 and 20, 2 and 10, 4 and 5. 4 and 5 are those factors that can go to negative 9, so I've got x minus 4 and x minus 5. I'm going to set each of those factors equal to 0. So x minus 4 is equal to 0, x minus 5 is equal to 0. Solving, I get x is equal to 4 and x is equal to 5. So again, factoring works best when you can easily break down that c value to get a pair that can add or subtract to the b value. Completing the square. This is going to work best when our x squared value has a leading coefficient of 1, and there are no obvious factors of 12 that add up to that middle number of negative 5. So there are no obvious factors here. So I'm going to go ahead and complete the square. I'm going to look at the b value, which is negative 5, take half of that, which is negative 2.5, and then square that, which is going to give me 6.25. I'm going to go ahead and add that to both sides of the equation, which gives me x squared minus 5x plus 6.25 is equal to 18.25. Factoring that down, I'm going to end up with x minus 2.5 squared is equal to 18.25. I then need to take the square root of both of those sides. To get my two cases, I get x minus 2.5 is equal to 4.27, and x minus 2.25 is equal to negative 4.27. Solving both of those cases, I'm going to go ahead and add 2.5, and the first answer is going to be 6.77. Adding 2.5 to the second one, my answer is going to be x is equal to negative 1.77. The last option that we have is the quadratic formula. Again, this works best when there is a leading coefficient other than 1, and or it will work for all of the problems. So if you want to be consistent and just use the quadratic formula, that is fine unless it specifies that you have to use otherwise. So I'm going to take the negative of b, which is positive 4, plus or minus the square root of b squared minus 4 times a times c, being careful that you have that negative with the 11, all over 2 times a. Simplifying this down, I'm going to end up with 4 plus or minus the square root of 16 plus 176 all over 8, which continues to simplify to 4 plus or minus the square root of 192 all over 8. Plugging both of those into the calculator, the first one with the addition for plus the square root of 192 divided by 8 is going to give me an answer of x is equal to 2.23. And the second one, where we are subtracting that square root value, gives me x is equal to negative 1.23. So again, our two answers. If you have questions about this or anything else from the lesson, please let me know when you get to class.